Hello class, today we're going to be taking notes over center, spread, and shape. There is no paper for you to cut and glue today. It is just going to be some handwritten notes because there's no paper. So when we talk about center, spread, and shape, it is how we're looking at data, how we describe data. So when we use the word center, the center and put center in quotes. So the center is measured by the median. So if I want to know the center of something, I figure out where the median is at, and that is the center of my graph, the center of my histogram, the center of my line plot, the center of my box and whisker plot. It is the median. Then we talk about the word spread, and the spread is measured by the quartiles. Now if you remember back to box and whisker plots, those are quartiles. The 4 quartiles of a box and whisker plot, they're spread out by the median, so it is your spread of numbers, how far apart they are spread apart. So we'll put spread apart down below. Then if we look at the shape, the shape is what it looks like. It describes the distribution of numbers. So that's your center, your spread, and your shape. Most of the time when we talk about center, spread, and shape, we're talking about how our numbers are spread apart and how they go with your shape. Okay, so there are 3 pictures that we are going to draw, and they're going to be 3 histograms, but we could do this with line plots as well. So I'm going to draw 3 L's on my paper like so. And then I'm going to draw, it doesn't have to be perfect, but I'm going to draw a picture like that. Then I'm going to draw one like that. And the last one like this. So take a minute, pause this video, finish getting these drawn down. When you're done drawing them down, unpause this video so we can discuss these 3. These 3 graphs tell us what our data looks like, and it goes with the word skewed. So we have 3 different ones. We have skewed left, skewed right, and symmetric, and there's one of each of them here for you. So the way that this works is this is symmetric, and hopefully you guys remember symmetric from your elementary days, where it's the same on both sides. So when something is symmetric, this means the left side of the graph mirrors the right side. meaning they look exactly the same. So when they look the exact same going up and going down, it is symmetric. Now one of these is skewed left, one is skewed right. Okay, now obviously I don't expect you to know that, so here I go, I'm going to tell you. This one here is skewed left, which means this one is skewed right. What this means is it means what we call the tail extends to the left. So here's what I mean by the tail. If I were to draw a picture, a line, goes kind of like that. This part here is the tail of your graph. It is the bottommost part of your graph that all swoops down to one location. So if the tail is on the left, that means most of the data is on the right. So it's like the opposite of what we think. So that means skewed right is the exact opposite. It means the tail extends to the right. So if I draw my picture, my tail is right there, which means most of the data is on the left. It is the opposite of what we think. So if you can remember that and you can remember the opposite, it's the opposite. If I see something, or we just got to remember where the tail is at. It's on the left, the right side, so it's skewed right. Tail is on the left side, so it's skewed left. So I'm going to give us a set of numbers. Here's our example. You'll be given a set of numbers like 4, 3, 1, 2, 4, 3, 2, 1, 0. Two, 0, 1, 1, 2, 2, 3, 5, 2, 1, 2, 3, 1, 1. So you'll be given a set of numbers and they're going to ask you something like either to draw a line plot or to draw a histogram. Either one. Our examples are in histograms, but we can do them in line plots as well. So I'm going to say draw a line plot. So that means we need to draw a number line. I need to find my smallest number. So if I look in this list of numbers, my smallest number I see is a 0. And I need to find my greatest number. The greatest number I see is a 5. So I want to count from 0 to 5 by ones because I want to use equal intervals. So I will have 1, 2, 3, 4. And now that my number line is drawn, I can now go and make my X's. So I can see that there is 1, 2 zeros. I see 1, 2, 3, 4, 5, 6, 7 X's. I see 1, 2, 3, 4, 5, 6, 7 2's. I have 1, 2, 3, 4 3's. I have 1, 2, 4's, and I have 1, 5. So once you've plotted it, you then need to tell me, is it skewed left, is it skewed right, is it symmetric? So if I look at this number line, first thing I'd rule out is it symmetric, yes or no? Is it exactly the same on both sides? Is it mirrored? And if I ask myself, is it mirrored? No, it is not. I do not have exactly the same on one side as I do the other, so it is not mirrored. So that means it is either skewed left or it is skewed right. The question is does my tail end on the left side or does my tail end on the right side? Where is the majority of my tail? It's the opposite of where the majority of your data is. So if we look at this, the majority of my data is on the left-hand side, which means my tail is on the opposite side, so my tail is on the left, or on the right, excuse me. So that means right here is my tail, which means my answer in this case is skewed right. So most of my data is on the left, my tail is on the right, therefore it is skewed right. Okay, I'm going to have you do one on your own. I'm going to flip my page here. Retitle it. So I'm going to give you another one. Let's do 5, 6, 4, 5, 3, 2, 4, 6, 1, 3, 5, 4, 3, 2, 5, 4, 5, 3, 4, 5. So there are your numbers. I would like you to draw a line plot and describe the distribution. Is it skewed left, skewed right, or symmetric? So I want you to do one on your own. We'll talk about it in class. We'll do a few more questions in class as well for practice before we give homework. So good luck. Make sure you come to class prepared. Make sure you come with questions because I know that this is a really weird topic. Have a great rest of your evening. I look forward to seeing you guys tomorrow. Bye-bye.